Hello, my name is James Charles and I'd like to tell you about our paper on scaling digital screen reading with one-shot learning and re-identification. Many different types of digital meters are used on a daily basis, be it for home health monitoring or in the medical industrial sector. However, many still do not contain wireless connectivity. Hence, connecting these devices to phone tracking apps or control centers either requires cumbersome manual transcription or is not plausible due to costs. Our motivation is to cheaply and in an environmentally friendly way retrofit these types of meters with smart data transfer capabilities using a mobile phone app and limited training data. The idea is a user can wave their phone camera over the screen of a meter to quickly transcribe the readings, in addition to keeping an image-based audit. The system should also scale to multiple meter types and be able to recognize automatically which meter is being read. The system is trainable from a single labelled image of the target meter, in this case a blood glucose meter. A silhouette mask and a screen bounding box is all which is required. Once trained, the system can then work in many environments, different lightings and meter orientations. Here we show a demo of the final app reading the glucose, time and date from a blood glucose monitor. Notice tracking of the screen is robust and readings are transcribed reliably. The system is very accurate. Across a range of different types of meters, we obtain read accuracies close to 100%. This is reassuring, particularly when dealing with medical data. The system works by first acquiring an image of the target meter using the mobile phone camera. A meter re-identification system then retrieves the meter's template from a gallery of digital meters, so as to identify the meter make and type. With this, a meter-specific reading module is selected, which is trained to locate and rectify the screen of the meter and then pass the reading held on screen. All of these components run in real time on mobile phone. The re-identification system is a neural network which produces an embedding for the images of digital meters. We train this embedding from 10,000 images of digital meters downloaded from internet image searches. The network is trained to produce similar embeddings for each digital meter, but under various affine transformations. To detect the digits, we propose a network called the digit, which is trained to output pointwise heat maps for each digit respectively. The digit is extremely efficient to run on mobile phone. For screen detection, we use the one training image and augment it with random backgrounds. We simulate perspective distortion and train a network from this data to regress to the four corners of the screen. In practice, this simple approach does not work very well due to the large domain shift between the synthetic data and real-world data. We overcome this with the use of a modality converter. This takes the real data and the synthetic data and converts them into a domain which preserves screen geometry but reduces the domain shift. We can then train on the converted synthetic data and at test time apply the same conversion to real data. We test on 5 different digital meters, shown here. And here we show qualitative results in a video demonstrating the robustness of the screen detector under various rotations, lighting, and background clutter. Notice for the multimeter, due to the device-specific training, we detect only the multimeter of interest and do not become confused by those in the background. Quantitative performance of screen detection precision is shown in these graphs. Higher curves means better precision. We discover that using a modality converter, which produces an edge-based image, works best and transfers well to the real world. To evaluate meter re-ID performance, we hide the 5 template images of our test meters in 10,000 images of digital meters. The task is to retrieve the template image when supplied with an image containing the same meter. We test 30 image retrievals for each of the 5 meters and achieve a 96% top 1 accuracy. To summarize, we've demonstrated an automatic meter reading system trainable from a single image. It can scale to different meters, is extremely accurate, and runs in real time in the wild on mobile phone. The mobile phone framework is now also employed in a commercial setting by GlucoRx Limited for scanning glucose meter readings and helping with diabetes management of their over 250,000 UK patients. Thank you very much for listening.